This is Mr. Bowen, and I want to look at some examples of transformations with you. So here's a function f of x equals 4x, and it says for the function we want to determine what the parent function is, and then we must sketch the given function. So if I look back at those parent functions that we've looked at, this looks to me a lot like the function f of x equals x, the identity function. And when I look at what's different about it, I see the 4 here. And to me, that's like multiplying the 4 by the function itself, the x. So what transformation that 4 will do is that it will multiply all the y's by 4. It'll stretch the graph vertically by a factor of 4. So what I find helpful sometimes in making these sketches is to plot out a few of the important points on the parent function, f of x equals x, like 0, 0, and 1, 1, 2, 2, 3, 3, negative 1, negative 1, negative 2, negative 2. And then think about what would happen if you multiplied the y value by 4 on each of those. If I took 0, 0 and multiplied the y by 4, 4 times 0 is still 0. So one of the points I need is right there. If I took 1, 1 and multiplied the y by 4, 1 times 4 is 4, it should be up here. The point that was at 2, 2 would be off our graph at 2, 8. And you could make it if you wanted to, of course. How about this point here at negative 1, negative 1? It should now be at negative 1, negative 4. And that should be consistent with your understanding from algebra of what the slope of a linear function is. This is linear, and the slope is 4, and that is consistent. That makes sense. So we'll sketch our function. Okay, this one's for you to try. Why don't you pause the video, see if you can figure out what the parent function is, decide what transformation or transformations are happening, and then sketch the function. The parent function of this function, g of x equals negative 2 square root of x, is the function square root of x. And what is this negative 2? Well, it's multiplied by the function itself, by the square root of x. So what that will do is it will multiply all of the y's by negative 2. So if I go back and look at the square root of x function, the parent function here, it really kind of has a first point. Its domain is not all real numbers. Its first point is at 0, 0. There's a point at 1, 1. There's a point at 4, 2, because the square root of 4 is 2. So if I thought about multiplying each of those by negative 2, the point at 0, 0 would be at 0, 0 still. But the point that was at 1, 1 would be at 1, negative 2. The point at 4, 2 would be at 4, negative 4. It's possible to think of this as two separate translations, or transformations rather, if you thought of the negative and the 2 being separate things. You could think of it first as the 2 stretching the curve vertically by a factor of 2, and then the negative flipping it across the x-axis like a mirror. Either way you think about it, this is going to reflect the graph down to quadrant 4. Like so. Okay, got one more for you to try here. Pause it, see if you can find the parent function and sketch this function, and then hit play to get some feedback. So the parent function in this case, the function that is the head of this family, is the x squared function. And I can see that when I see, something squared. So this is going to be a member of the family of x squareds. Now, the thing that's different about this one is this one actually has two transformations. And as we'll talk about later in Learning Target 2, the order matters. So I want to think about what would happen if I put some number in for x. In what order would that number encounter these transformations? The plus 3, and then the minus 1. If I put some number in for x, the very first thing that it would encounter would be the plus 3. And that tells me that I need to consider it first. So the first thing we want to do is think about what would happen if I added 3 to the input of a function. And this is the thing that does kind of the opposite of what you might expect. It doesn't shift the graph right 3. It shifts the graph left 3 units. After that number has 3 added to it, we would square that number, and then whatever number that is, we would subtract 1. So that's the last thing to deal with. And subtracting 1 from the function itself would shift the graph, would translate the graph down 1 unit. So to make a decent sketch of our graph, let me think about what the parent function graph looks like. It has a point at 0, 0, at 1, 1, at 2, 4. It also has a point at negative 1, 1, and negative 2, 4. And now let's think about taking each of those key points through our sequence of transformations. If I take the point at 0, 0 and shift it left 3, 1, 2, 3, and then down 1, the point should go here. If I take the point at 1, 1, left 3, 2, 3, and down 1, it should be at negative 2, 0. If I take the point from 2, 4, left 1, 2, 3, and down 1, we're at negative 1, 3. The point at negative 1, 1 goes left 2, 3, and down 1 to negative 4, 0. The point at negative 2, 4 goes left 2, 3, and down 1 to negative 5, 3. Not the best graph we are sketching. There we go.